Okay, question 20. We've got a circuit, we've got two wires connected in series, and we have got another piece of information where it says the diameter of wire B is 3 times larger than diameter of wire A. So describe and explain how the current, charge carrier density, and drift velocity compare in wires A and B. So let's start with current. Okay, so there we go. We're going to start off with current. So this is a series circuit. So therefore, the current everywhere across the circuit is the same. And that's where you say cables are in series, so current will be the same in each. That's question one. First mark, sorry. The second mark, let's talk about the charge carrier density. Okay, so it's the number of charge carriers within that material. Now, it says that two samples of a conductor of equal length are connected in series. So they are made out of, here the key part, same material. So that means that the charge carrier density on each one is going to be exactly the same. So cables made out of same material, so N will be the same for each. And that's the charge carrier density in that formula there. So we've got the current the same everywhere, and now we've got the charge carrying density the same everywhere when we're looking at this drift velocity equation. The next thing that we need to discuss, so far we've got 2 marks, and out of 4 is the drift velocity. Because the current and the charge carrier density is constant and it's the same in both, that means that the cross-sectional area is inversely proportional to the drift velocity. Okay, so that's something that we can take away from the first two statements. And because we've got, so we can just write that down, that the cross-sectional area is inversely proportional to the drift velocity. We can see that wire B has a bigger cross-sectional area, and it says that diameter of YB is 3 times larger than diameter A. So one statement we can say is the diameter, because it's got a larger YB, has a larger cross-sectional area compared to A, so therefore its drift velocity is going to be smaller. Okay, so YB is going to have a smaller drift velocity. Now, that's something that we can say as a general statement because we've been given specific dimensions so that the diameter of wire B is 3 times larger than diameter of wire A. Okay, so we know that the current in A and the current in B are exactly the same. Okay, so we know that the current is equal to the charge carrier density times by the cross-sectional area times by the drift velocity times by the charge of an electron. So we know that the current in A is equal to the current in B. So that's just the current in A and that's just the current in B. The charge carrier density is the same in both. So I'm just going to cancel that out. The charge is the electron, and therefore we've got the cross section of A multiplied by the cross section of the drift velocity of A is equal to the cross section of B times by drift velocity of B. Now this is a cylindric shape, so it's pi r squared in terms of cross sectional area. So if the radius of A is r, we know that the diameter of B is 3 times larger. That means the radius is also 3 times larger. So if the radius of A is r, then the radius of B is 3 times that, 3 lots of r. And that's inside of the square because it's pi and whatever the radius is, which is 3r all squared. And what we see is that the r squareds cancel and then you leave with a 3 squared, and that's the drift velocity of in A is 9 times bigger the drift velocity of B. Okay, we did say as a general statement the drift velocity of B was less than the drift velocity of A, but this is more specific. We can say it's drift velocity of A is 9 times the drift velocity of B, and that there gives you your second and third mark. No, third and fourth mark, sorry.